chandelier.
Nice
And
chandelier.
thank you. I love it. I don't know how to hang it though. It doesn't stay up. I'm trying to put it in the office.
Okay.
So I really need help.
You need help. Okay, so let's draw a diagram first. Okay, so here's the chandelier. You know, this is A, this is B, and this is C.
Okay.
Right? Now, what do you know?
I know that this weighs 10 kilograms.
Okay, so it's 10 kilograms. Okay.
I also know that the force of gravity is 9.8 meters per second squared. I know that this angle equals 30 degrees.
Okay.
I know that this tension has to be 2 times that one. So that wire has to be,
So you know the tension of
yes, we call that tension CB, I guess.
CB equals 2 times tension
Of
CA?
CA, yes.
Okay, cool.
Okay. What I don't know is, I don't know what this angle is, so I guess we call it angle theta.
Okay.
I don't know the force acting on this tension C. And I also don't know tension CA and tension CB.
Okay.
Okay.
Cool. Alright, so we know what our knowns are. We have our unknowns. We got to find these. So now we have to come up with 2 equations. We have to first come up with an equation for summation force in the x direction, and another equation for summation force in the y direction, so we can solve our unknowns.
Okay, and they have to equal 0.
And they do have to equal 0, yeah.
Thank you.
Bye. You got
I
this.
can't do this
You got
alone.
this. You got
Phyllis!
this. No.
Okay.
So we're going to start by making a free body diagram.
Okay. Move my chandelier.
Okay, so we're going to split up these 2 tension forces into their x and y components so we can make 2 equations. So we have the tension of CA in the x direction, and we have the tension of CA in the y direction, and then you have the same thing on this side. So then we're just going to write the 2 equations. So we have the sum of our forces in the x, which is going to equal the tension of CA times the cosine of our angle here, which we know to be 30, plus, actually minus because they're pointing in different directions, the tension in CB times the cosine of our unknown angle theta, and that's going to equal 0.
Okay. Because they all have to be 0.
So your chandelier stays steady. And the sum of forces in the y direction are going to be pretty much the same, except we're going to use a sine instead to get the vertical components. So we're going to add to this the tension in CB in the y direction, which is tension CB times sine of our unknown angle. And we're going to subtract from that forces that are coming in the opposite direction,
The C
which is just our 10 kilograms
of the chandelier.
of the chandelier
And then
times 9.8 meters per second squared, which is going to give us 98 newtons. We're going to subtract 98 newtons here, and that's also going to equal 0.
Okay.
So I'm pretty sure you got it from here.
I need your help. Phyllis
Alright.
helped me find the sum of the forces in the x direction, and we got this equation. And then she helped me also find the sum of the forces in the y direction, so we got this equation. But we have to actually find the unknowns.
Okay.
So
Alright,
I'm
so
gonna try to
we'll
start
take
it.
the summation force in the x direction and find theta, alright? So
Okay.
let's rewrite the equation over here. Alright, so it's summation of forces in the x direction equals,
Negative TCA
okay,
cosine 30
cosine 30 degrees.
plus TCB cosine theta has to equal 0.
Has to equal 0. Alright, so we see that we need to solve for theta, right? One of our knowns is that TCB equals 2TCA. So we can take that and plug it into our equation,
Okay.
right? So, negative TCA cosine 30 degrees plus 2TCA cosine theta is equal to 0.
Okay, I think I can do this part.
You got this? Alright,
Yeah.
why don't you try it?
Okay, so move over this portion to the 0 side to cancel it out. Plus TCA cosine 30 degrees 2TCA cosine theta. And then we can divide by 2TCA. Cancel that out. It's 2TCA. And then you can cancel out the TCAs. And then simplified, cosine theta equals cosine 30 degrees over 2. And then, okay. So then, once we get this portion simplified, we can take the inverse of cosine, this cosine to -1, times cosine 30 degrees over 2, which is going to equal our theta, which is 64.34. Roughly. So theta equals 64.34 degrees.
All right. Nice work. You got
Thank
it.
you, Jim. Thank you.
Welcome.
Okay, so we know theta equals 64.34 degrees. So I'm just gonna, I guess, put it here for theta, what we know now. But we also still need to find some of the forces in the y direction. So I guess I'm just gonna erase this. Maybe Pam can help me. Pam!
Hey, Michael.
Okay, I need to find the answer for these unknowns and some of the forces in the y direction.
The y
Do
direction.
you think you can help me?
I think so.
Okay.
Okay, so what is our formula? F in the y direction equals
TCA
TCA
sine 30
sine 30
plus TCB
plus TCB
sine theta
sine theta
minus 98 newtons
minus 98 newtons
has to equal 0.
equals 0 because it's equilibrium. Okay, so the first thing we're going to do is replace TCB with 2TCA because that's f of y equals TCA sine 30 plus 2TCA sine theta, and we can move over the 98 newtons since that's a constant.
Okay.
So the next thing you're going to do, we have a common factor, so we're going to pull that out, TCA, and you're going to be left with sine 30 plus 2 sine theta, all equals 98.
Okay.
Next thing we can do is divide this 98 by this whole expression, and that equals TCA equals 98 all over sine 30 plus 2 sine theta. A equals 98 over sine 30 plus 2 sine 64.34. Okay, so now we just plug this whole thing into the calculator. So we get that TCA equals 42.57 newtons.
Okay. I see it.
Great.
Okay.
42.57 newtons.
Okay. Okay, so 42.57 is the force of A, so we can erase this. This is known now. And TCB equals 2 times the TCA. So if I take 2 times the 42.57 newtons, that's going to equal 85.14 newtons for B.
Oh, look. She finished it.
Wow, so impressive.
All right. So let's see what she did. Let's check her work, all right?
For theta, we got 64.34 degrees.
So theta equals 64.34 degrees, right?
Yes.
And then she solved for summation for the tension in cable CB, which was
85.14 newtons.
85.14 newtons. Tension in CB,
And the tension in TCA was 42.52 newtons.
42.52 newtons. All right. Summation of forces in the x direction equals negative 42.52 cosine 30 plus TCB, which is 85.14 cosine 64.34. Okay. So if you plug that into our calculator, 0.
Well, then we did something right.
All right. Now we gotta solve for the summation of force in the y direction.
Okay.
Let's check our work. So summation force in the y direction. So TCA, which is 42.52, sine 30 degrees, plus TCB, which is 85.14 sine 64.34 minus 98. Alright, so plug that in. Sine 30 plus 85. Alright, that equals 0.
Great job.
Sweet, we got it. Alright. Let's surprise
Let's
her.
hang this baby up. My beautiful chandelier. She's staying still. That's all I ever wanted. And she equals 0. I guess you could say the office tension is relieved.